A lot of probability questions are asked about a standard deck of cards. So you need to know some basics about a standard 52 deck of playing cards to be able to answer these types of questions. So what you need to know is that there are 2 black suits, clubs and spades, and there are 13 each of every suit. Then there are 2 red suits, hearts and diamonds. Again, 13 of each, because 52 divided up by 4 different suits gives you 13 each. For our purposes, aces are not considered face cards because there is not actually a face on them. And they're also not considered number cards because they could take on number 1 or number 11 or be various other things depending on what game you're playing. So they don't count really as either. Aces don't. The jack, the queen, and the king are face cards. Okay, so you may get any type of probability question about these, and those are the things you want to know in order to answer these questions. So let's answer several probabilities. It says, find these, giving all answers as fractions in lowest terms. Suppose you're drawing a card from a standard 52 card deck. Find the probability of drawing a heart. Okay, so the probability of drawing a heart is out of the 52. We know that there are 13 hearts. And if we reduce that, we get 1/4, which makes sense. There are 4 suits. Hearts is one of those suits, so that would be 1 out of 4. What's the probability of drawing a red card? Well, out of the 52 total cards, we have both diamonds and hearts that are red. So we have 26 total red cards, which reduces to 1/2. And that again should make sense looking at this image. Half of those cards are red, 50%. What's the probability of drawing not a red card? Well, that is 1 minus the probability of drawing a red card. So 1 minus 1/2, which is also 1/2. Well, the only thing that's not red in this case is black, so it's the other 50%. What's the probability of drawing an ace? So there is an ace of every suit, which means there's 1, 2, 3, 4 aces. So 4 out of the 52 cards are aces, and reducing that reduces down to 1 out of 13. What's the probability of drawing a black ace? So the probability of a black ace. Well, there's only 2 of those, the ace of spades and the ace of clubs. So 2 out of 52 cards, which reduces to 1/26. What's the probability of drawing specifically the ace of spades? Well, there's only 1 of those out of 52, so that is just it. What's the probability of drawing a purple card? Are there any purple cards? There are not. That's a silly question. 0 out of these 52 cards are purple, so just 0%. What's the probability of drawing a red card or a black card? So the probability of red union black. Notice, can a card be both red and black at the same time? It cannot be. So this is going to be just the probability of drawing red plus the probability of drawing black, which we already know is 1/2 and 1/2, basically from parts B and C together. And that gives us 1. And that again should make logical sense. I have a 100% chance of drawing something that is either red or black. Those are the only 2 options. What's the probability of drawing a king? Well, let's see, out of the 52 cards, again we have a king of each suit, so this is the same as drawing an ace from part D. There's 4 out of 52 of those, so 1 out of 13. What's the probability of drawing a king or a jack? So ask yourself, is there a way to draw a king and a jack at the same time? Can the same card be both a king and a jack? No, it can't be. So these are also mutually exclusive, which means we should simply add probability of king plus probability of jack. So there are 4 kings and there are also 4 jacks. So we get 8 total out of the 52 cards, which reduces to 2/13. It's the probability of drawing a number card. Let's see, you might actually need to go back and look at these. So number cards are basically 2 through 10. That means there's 1, 2, 3, 4, 5, 6, 7, 8, 9 of those for each suit. And then there are 4 different suits. So there are basically 9 times 4. There are 36 of these types of cards. 36 out of 52 reduces to 9/13. What's the probability of drawing a face card? Remember, for us, face cards are only jacks, queens, and kings. So there's 1, 2, 3 of those times 4 different suits. So there are 12 total. And 12 out of 52 reduces to 3/13. What's the probability of drawing an even number card? So again, I may have to go back and look. Let's see, even number cards would be the 2, the 4, the 6, the 8, and the 10. So there are 1, 2, 3, 4, 5 of those of each suit times 4 suits, which means there's 20 total of them. And that would be 5/13 when reduced. What's the probability of drawing a face card or an even number card? Probability of face or even number. Yet again, ask yourself, can you draw, or can the same card be both a face card and an even number card? No, it can't. So these again are mutually exclusive, which means all we need to do is add the probability of a face card plus the probability of an even card. And I'm just going to go get their reduced forms. So that is the 3/13 from earlier plus the 5/13, which means 8/13. So it's really nice when you're doing a bunch of these in a row to just go back and grab things you already know. And finally, what's the probability of drawing a heart or a face card? Let's see. Can you have a heart that's also a face card? You can. So here we have to be very careful. These are not mutually exclusive. So when we calculate this, we have to take the probability of heart plus the probability of a face card minus the probability of the intersection of a heart and a face card. So let's see. We already know, or we know the probability of drawing a heart from part A is 1/4, but I'm going to go ahead and grab its unreduced form just for easier adding. That's 13 out of 52. And the probability of drawing a face card in unreduced form is 12 out of 52. But I've counted some twice. I've counted the heart face cards, the ones that are both, twice. So how many is that? How many hearts are face cards? The jack, the queen, and the king. There are 3 that are both. Those have been counted twice. So I need to subtract that out 1 time. So let's see, if we add that up, we would get 15, but then we have to take out 3 of them, so we get 12 out of 52, or 3/13.